Hello everyone. So this is part of course AML, and here's the task is to present this paper reading presentation. I selected this paper, Deep Active Learning for Name and Data Recognition from the conference of ICLR 2018. So let's start with this motivation. So the real motivation is to select actually the label from the sample from large database. So here, what active learning is doing that it for deep learning tasks in the NER descriptor, which is popular since so much time before 2018. So here we want to achieve good accuracy on the samples. Before applying DNN architecture on the data sets, we first need to select the samples with the help of active learning. Learning approaches is discussed in this paper, and after that active learning we actually first select some active samples and labeling that, because labeling of large data sets is actually too much expensive in the case of NER description, because the language have too many tokens and too many words. So labeling all these will be costly. So first, with the help of active learning approaches, we select that pick up more important samples and give that to training, DNA training. So let's start with what before that training we apply some of the NER model description techniques to improve that data sets. So first, that what we need to do in this, we need to understand that. So tokens are actually placed in from start and conclusion at the end of sentence. So accordingly, similar length of sentences can be grouped in a similar type of buckets, and further that tokens can be added into sentence and make their length actually uniform, because in the case of this any description, length is really more important, because large sentences take a lot of time, and that may cause problem. So further we do a character level encoding and word level encoding. So that will actually help to drop out some of the CNN layers, which will help to improve the whole data sets. In between the that layers, we max pool that and take out the best performance character level encoder to ensure the representation of words will consistent during the whole length. That similar way we will do word level encoder. And with word level encoder, that is your approach since 2012, that word to vector training, and that actually embedded to initialize the throughout the sentences of every token, and generalize the word in during training data. So here we can see in these images, like here's the first character level encoding, and second is the word level encoding. So how this will approach to one layer to another layer, and the word will be this is the sentence for sample we have taken. BOS and EOS is the start and end of the this, and here character level encoding we characterize max pooling for every character taken KATE, and again BOW start of the word and end of the word we've taken, and that way we actually perform all the encoding of characters as well as the words. For second, further we need to tag decoder. Tag decoder actually generates the probability distribution across all the sequences in the all world level encoder. That is the next step to improve this performance. So further, actually tag decoder is to is actually is provide the LSTM INN approach, and that computes every edge with decreasing of I plus L, and that will actually represent the next word in the encoding. And using this softmax loss function, we will further improve this decoding, and as we perform one sentence, we can move to another step of sentence in this way. So this is the architecture diagram which is presented in the paper, STM architecture of tag decoder, which I said that we have to first tag this in the way that we will take that cat lives on the master, so we have to tag every word that way and encoding. So first we did the word level encoding, then after we have to apply the tag decoder here. So computationally, actually, it interact with batch sequence of tags with LSTM decoder, and it actually apply with the greedy approach. So it actually to improve the performance of the iron tags. So here now we will approach the next, the main part of this paper, which is active lining. So to majorly solve the problem of manual annotation, which is the actually a big problem of any examples and samples, we actually have to do the first statistically find out how we can take out the samples. So there will be few annotations, and that can be labeled with the help of active learning approaches. So first, in active learning approaches, we have to predefine some budget, that how many annotations are there, and the how many parameters are there in the training in augment data set, so we can proceed to next rounds. Further, we assume that cost of annotation a sentence is proportional to the number of words in the sentence, and that every word in the selected sentence must be annotated at once. Okay, that way authors actually not allowed to account for partially annotated sentences, because that can decrease the performance in the training, further training. So we consider the ranking methods, and which we will discuss further. Ranking methods which will actually apply on the sentences, and we can try to find out which have the large rankings. Then we can select on this on the basis of CNN-CNN-LSTM architecture approaches which applied on NER. A first approach which is used in this paper is least confident approach. Least confident approach is an active learning approach, which actually proposed by Coletta McClure in their paper in 2015, proposed to sort example in ascending order according to probability of assigned by the model to most likely sequence of text. This way, they will actually sequence of they may make a sequence of tags according to LSTM decoder, and that determines the most likely sequence which can be used in further DNN training. Next approach is maximum normalized log probability. That actually can be transformed by the family analysis of LC method, which can be select longer sentences. So if there are longer sentences, we have to perform active learning as per the maximum normalized log probability. That way, so it's actually this method can do the sorting in the ascending order, and which actually favors longer sentences. Longer sentences require more labor for annotation because they find this undesirable. So we have to use this maximum normalized log probability method for specifically long sentences. So further approaches of active learning is Bayesian active learning by disagreement. This is in short form, but actually author here considered that the sampling according to the measures of uncertainty objective considering between dropout and deep question processes. These papers were earlier presented, and they proposed that variability of prediction over success forward passes due to dropout can be interpreted as measure of model uncertainty. This way, we can improve also on the approach of active learning, and then we can select after it the samples, we can give that to DNN architecture. So here is the final experiment results, that how the this actually shows that F1 score, and here is percent of word annotated, how many words are annotated, it's in the percentage. Okay, and there is a F1 score accuracy. So and these color lines showing the different active learning, and these dotted lines actually shows the standard deep model architecture, how they are performing. So we can see that with the help of MNLP, their accuracy is actually increasing for especially in Chinese. There are two data sets. We have taken 1.5.0 English and 1.5.0 Chinese on the data set on two data sets. So this way they show that the accuracy is increasing from the standard deep model architecture, because they are using LC and MNLP. So these architecture are better performing with the help of active learning in this paper. So let's talk about the limitations. So limitations come from how better can be done and what the negative things are there. So here active learning method picks sometimes there are chances, and majorly this is observed that they sometimes picks examples independently of each other, and they may choose sometime comparably examples which are all not contribute significantly. This actually may lead to the multiple examples which can be biased is towards one side. So that need to be reduced. There is need to be reduced the that consecutive samples. Also, I observed that there is absence of transfer learning. We can use in specifically NLP, NER description modeling. We can use pre-trained model, which is already trained on some samples of language, and then we can perform active learning and then DNN architecture learning that can improve significantly more. So here is some overcome the limitation. Here are some suggestions for possible improvement. So we can actually reduce the redundancy while choosing the similar samples. So we can apply active learning approach, which can actually reduce similar kind of sets doing that, and it actually reduce the bias. And transfer learning can be applied with the help of pre-trained model, which can also significantly improve the performances. This is from my side. Thank you. Thank you so much.